Hi class, this is Mrs. Lyons. The purpose of this video is to explain the trend of ionization energy. Okay, ionization energy is the energy required to remove the most loosely held electron from an atom in the gas phase. Okay, so what does that mean? When it says it's in the gas phase, that really doesn't affect us at all. Basically, there's an instrument that is used to measure energy, and in order for it to measure the changes in energy, the atoms have to be in the gas phase. Okay, what we really care about is the amount of energy needed to remove the most loosely held electron. Okay, so the most loosely held electron is going to be an electron out in the valence shell, in the outermost energy level of the atom. Okay, a high ionization energy means it's hard to remove that electron. Okay, when we remove an electron, we form an ion. An ion is an atom where the protons and electrons are not equal any longer. We've talked about cations. A cation is formed when an atom loses an electron and becomes positive. Remember, we said cats have paws, therefore a cation is positive. That's our little trick for remembering cations. All right, and we're only talking about cations in this video because ionization energy is the energy it takes to form a cation. So the first trend we want to look at is the group trend. Okay, so what happens to ionization energy within a group? So we're going to look at lithium and rubidium. Both of these atoms both of these elements have one valence electron. Okay, so lithium has one valence electron, rubidium has one valence electron. Okay, ionization energy is going to be the energy it takes to remove that electron. Okay, so what's going to be harder, to remove an electron from lithium or to remove an electron from rubidium? Okay, here's what we have to consider. In lithium, there's only one energy level between the nucleus and the valence electron. What this means is the attraction from the nucleus to that electron is strong because there's nothing really to keep the nucleus from pulling on that electron. In rubidium, however, if you look, there are 1, 2, 3, 4 energy levels between the nucleus, and the nucleus is positively charged, and this valence electron that's trying to be removed. Well, what happens is this electron is easier to remove. And the reason for that is it's something called shielding. And basically what we're saying is all of these electrons in between the nucleus and that valence electron are like a shield that allow the electron to be removed more easily. They're shielding that valence electron from the positive charge. Okay, so the more energy levels there are between the nucleus and that outer electron, the easier it's going to be to remove. So ionization energy is greater at the top of a group than it is lower down in the group where there are more energy levels to provide this shielding effect. Okay, so that one's not bad. Now we want to talk about what happens when we move across a period. Okay, and we're going to use this same, we've got period 2 elements, and the thing that remains constant here is that each of these atoms, each of these elements has two energy levels. Okay, so the valence electrons are in the second energy level for each of these elements. And just like we talked with atomic size, we said the atomic radius of an atom decreases as you go farther from left to right. And we said that the reason that was the case was because For example, fluorine in this case has 9 protons, whereas lithium only has 3 protons. Okay, so it's all about forces of attraction. Okay, lithium is kind of it has a weak nucleus. Okay, because it's only got +3. So it's going to be fairly easy to remove one of those electrons. Whereas fluorine, its nucleus has 9 protons. It's much more positive. As a result, it is going to hold on to these electrons. It does not want an electron to be removed. Okay, so the ionization energy for fluorine is much greater than the ionization energy from lithium. And it has to do with that whole idea of attractive forces. The more positive the nucleus is, the stronger the attraction for those valence electrons, which means it takes more energy to remove them. Okay, so hopefully this little video has helped kind of explain ionization energy and the trend as you go up and down a group and from right to left in the period. I hope this helps, and I will see you in class. Have a great day.